Note 13, continuing to solve trig equations, guys. I put a whole bunch of notes here, but I think I'm going to mix it up. I'm going to start with the easy stuff first because you don't really use any formulas until maybe sometimes when we don't have a perfect coordinate, and I'll show you how to use that later on. So go all the way to the easy stuff. Where's the easy stuff? Let's go right here where it says inspired by delta. Yeah, so look how easy these are. So whenever it's a perfect coordinate, all you need is your unit circle and hand. No yawning, guys. Those are demerits. They're not demerits, guys. I'm kidding. Yeah, stop. All right. What was that, a ghost? Halloween time. That was a joke, miss. All right, so here we go. Solve the trigonometric equation below for all values between 0 and 2 pi. And look what it says. Square root of 3 secant x equals negative 2. So the first thing you want to do is get secant x by itself, and you do that by dividing by square root of 3. So write secant x equals negative 2 over square root of 3. So do that. That's pretty easy, right? And then I know that secant is the reciprocal of which one? Cosine. So you can write it as cosine x equals negative square root of 3 over 2. And then from there, you can just, I guess you can just stop. Think about the unit circle. And think about where cosine x is negative square root of 3 over 2. It happens, let's see, where does it happen? It happens in quadrant 2 and in quadrant 3. What is this radian right here in quadrant 2? 5 pi over 6. And then which one's the one in quadrant 3? And there it is. Done. Would you have gotten those answers with what we learned last week? Yes. You don't have to write this down. You can just listen for this part. If you would have gotten x by itself, you would have gotten x equals plus minus arc cosine of negative square root of 3 over 2 plus 2 pi n. And then you would have said, oh, okay, well, that happens at pi over 6. That's the answer. That happens at 5 pi over 6. But I think the calculator would have spit out, yeah, maybe it would have spit out that one. Plus minus 5 pi over 6 plus 2 pi n. Chav, how do I get that 7 pi over 6? I don't see it. Well, look, guys, if you take the negative, I'm going to write x2. If I take the negative 5 pi over 6 and I add 2 pi, well, that 2 pi, I'm going to go ahead and turn it to 12 over 6. Well, look at that. Negative 5 pi plus 12, that is 7 pi. OMG. Do you guys see how our formulas are working? Yeah. Now, remember, the plus minus comes from somewhere. I'll show you where it comes from. All right, example 6. We're going to go slow on this one because this argument is not an x. I have a cosine 6x equals 0. So the first thing you want to do is get 6x by itself. And you do that by doing the inverse. Now, I like to put plus minus, but if you don't want to, that is fine. You don't have to put the plus minus, guys. Not for these when they're perfect coordinates. Chav, what do you mean by perfect coordinates? Where is cosine 0 on the unit circle? It happens in 2 locations. Correct, but I want it in degrees. In radians. Yeah, you said you said degrees, and I said I want it in radians. Sorry, guys. Sorry, YouTube. Yeah, so you could say 6x1 equals pi over 2 plus 2 pi n. And then you can go over here to the side and write 6x2 equals 3 pi over 2 plus 2 pi n. And don't worry, I'll show you that even with this plus minus, it would have worked. How do I get x1 by itself? And x2 as well. Divide everything by, yep, whatever you do to one, you do to all of them. So here's what you get. x1 equals pi over 12 plus pi n over 3. That's the period there, pi over 3. And then x2 equals 3 pi over 12, which reduces to pi over 4. Pi over 4 plus pi n over 3. 2 over 6 is 1/3. Yeah, I can see some of you guys. Relax. This pi over 4 is 3 pi over 12, and then I just reduced it. Pi over 4. Yeah, good notes. What are my answers? The answers are x equals pi over 12 comes first, and then pi over 4. And that's it, because my domain is between 0 and pi over 3. So my period is pi over 3. So if I had pi over 3, I would be outside the domain already. That makes sense, guys? You would have gotten these answers if you would have done plus minus. So you don't have to write this down. You can just listen. You could have gotten, so I'm just starting from here. I could have said 6x equals plus minus, that's pi over 2, plus 2 pi n. And then look, divide by 6, divide by 6, divide by 6. X equals plus minus pi over 12, plus pi over 3 with an n on the side. The pi over 12 is there, so no big deal with that one. Child, what about the pi over 4? How do I get that? You take the negative. Negative pi over 12 plus pi over 3. And then check it out. I'm going to turn this, I'm going to multiply by 4. So 4 over 12, right? 3 times 4 is 12. And then negative pi plus 4, that's your 3 pi over 12. And OMG, 3 pi over 12 reduces to pi over 4. Do you guys see how that works? So it doesn't matter how you do it. If you use your formula, you go with a little bit of logic, it's the same. All right, go to the next example. All these are perfect, so that's why all these are coming out like perfect for you guys. And don't worry, we'll give you guys time. I know it's kind of boring to just look at me do a whole bunch of problems, so we'll give you guys time to practice in a little bit. All right, let's move. How do I want to solve for x. I want all the answers between 0 and 4 pi over 3. So the first thing you're going to do is move the, no, not the 2, move the 1. 2 sine 3/2 x equals 1. And I know you're probably saying, when do I move it? When do I not? When do I solve? It all depends. It all depends, guys. Next, I got to get rid of the 2. How do I get rid of the 2? Divide. Sine of 3/2 x equals 1/2. Next, I'm going to do what? Yeah, inverse. So no, this one does not have a plus minus. This one I'm just going to write arc sine 1/2. It's actually pi minus arc sine 1/2 for the second equation, but we'll talk about that in a little bit. This is a perfect coordinate, 1/2. On the unit circle, sine is 1/2 in quadrant 1 and quadrant 2. Which one? What is the radian in quadrant 1? Do you guys remember? Not pi over 3. Pi over 3 is square root of 3 over 2. Pi over 6 plus 2 pi n. Because every time you do another 2 pi, it repeats. And then in quadrant 2, what is it? I'm going to write 3/2 x2. Perfect. 5 pi over 6. I know we haven't been doing the unit circle quizzes, guys, but the unit circle doesn't go away. We're going to use it the whole year. All right. Now, the last thing I do to get rid of the 3/2 is multiply by the reciprocal. Whatever you do to one, do to the other. Multiply by the reciprocal. If you have colored pencils or colored pens, here's a good place to use your colored pencils. So I'm going to put an arrow and write x1 here. x1 equals 2 goes into 6 3 times. 3 times 3 is 9, so I believe that's pi over 9. Plus 4 pi n over 3. I don't see any mistakes. 2 over 18. Yeah, 1/9. And then x2 equals 2 goes into 6 3 times. 3 times 3, 5 pi over 9. Plus 4 pi n over 3. So my answers finally are pi over 9, comma, 5 pi over 9. And there it is. How do we feel, guys? Okay. Nothing crazy, right? Okay. Nothing crazy. Unselect. Ask me questions. Where do you have any hiccups? We okay so far? Okay. All right. Now we want all the answers. Oh, by the way, in case you're wondering, why didn't I put more answers? I want all the answers between 0 and 4 pi over 3 My period is 4 pi over 3. So if you had 4 pi over 3, you'll already be outside the domain. In case, I don't know, some of you guys like to read it as 4 pi over 3. Some of you like to read it as 4/3 of pi. It doesn't matter. They're all the same. So, however you like to read it. All right. Last one before we get into some tricky stuff over here in a little bit. So we have this one here. It says I want all the answers between -6 and 6. So the first thing I'm going to do is move the square root of 3 to the side. So you're going to write 2 sine pi over 6, put the x on the side, equals -square root of 3. It should have parentheses, but it doesn't. That's what it means. It's part of your argument there. Nothing crazy, right? Okay, next, what do I got to do? Divide by 2. So now I have sine pi over 6x equals -square root of 3 over 2. Next thing, I'm going to get the pi over 6x by itself by doing the inverse. Equals arc sine of -square root of 3 over 2 plus 2 pi n. I'm going to come over here and I'm going to write both of them. So I'm going to write pi over 6 x1 equals, where is sine on the unit circle? -square root of 3 over 2. Let's see, I'll put it right here. It's going to be in quadrant 3 and in quadrant 4. The denominator is a 3. What is it? Yes. 4 pi over 3 is one of them. Plus 2 pi n. And 5 pi over 3 is the other one. Pi over 6 x2 equals 5 pi over 3 plus 2 pi n. We're still okay, guys? Last thing, multiply by 6 over pi. Whatever you do to one, you do to all of them. And here's what you get. I'm going to write this one first. x1 equals, let's see, 3 goes into 6 twice. 2 times 4 is 8. The pi's cancel out. Plus 2 times 6 is 12, and the pi cancels out. 12n. And then here's my x2. Let's see. 3 goes into 6 twice. 5 times 2 is 10. All I'm doing is this, guys. I'm just distributing. Plus, pi's cancel out. 6 times 2 is 12n. Here are my answers. One answer is 8. I said all because there's a negative answer in there, but I already wrote 8, so that's fine. The other answer, it can't be 10, but I can subtract 12 from 10, so one answer is -2. Actually, it can't be 8 either. Man, I'm not even paying attention here. Yeah, -2, and I have one other answer, -4. The -4 came from 8 minus 12. How do we feel, guys? I think. Well, the 12 is the period. So I can go positive 12 or I can go -12. N equals 1 or N equals -1. It just means if it equals 1, that means you did one rotation in the positive direction, I guess, quote unquote, or you went to the right. N equals -1 means that you went to the left, right? You went -12 to the left. So remember, N is an integer. So 12 is the period. I can just go 12, 24, however many you need. Okay. Let's go to the next one. Don't worry, guys. In a little bit, we'll get. You'll be more excited because we'll do delta and all that good stuff. All right. I'm gonna divide by square root of 3. And I have cotangent of 1/3 x equals 3 over square root of 3. I'm going to, what am I going to do? I'm going to rationalize this. I don't always rationalize, but I'm going to rationalize this. So you're going to have, let's see, 3 square root of 3 over 3. That cancels out. So I'm going to rewrite it. Cotangent of 1/3 x equals square root of 3. Then I'm going to do arc cotangent. 1/3 x equals arc cotangent of square root of 3 plus pi n. Cotangent repeats every pi. What's up? Only cosine has plus minus. Only arc cosine has plus minus. Yeah. I actually gave you all those notes over here in the first page, but I just haven't referenced it yet because all these coordinates have been perfect. Notice that the cosine has a plus minus and the sine does not have a plus minus. You have to do two different equations for the sine, but we'll get to it when we get to it. All right. Where am I at? Oh, yeah. I know we haven't graphed tangent and cotangent, guys, but tangent and cotangent repeats every pi. Repeats every 180 degrees, unlike cosine and sine. That's a wave. All right. Real quick, this right here means, well, it means this right here, right? I guess a side note. I'm just doing this just by itself. Side note. Arc cotangent of square root of 3 equals theta. That means that cotangent of theta equals square root of 3. So what does that mean? The only way you can get a square root of 3 is if you have a square root of 3 over 2 in the numerator and a half in the denominator, or a negative square root of 3 over 2 in the numerator and a negative half in the denominator. Remember that cotangent is x divided by y. Cotangent is x divided by y. So I need the x to be square root of 3 over 2 and the y to be a half. So that happens there, boom, and boom, in quadrant 1 and quadrant 2. Yeah, quadrant 3. I said quadrant 2, my bad. Sorry, guys. It's been a long day. For the seniors, I'm sure it's been even longer because you guys have probably been doing craziness. Okay. Yeah, I wrote like 7 recommendation letters, which usually takes me like 2 to 3 hours to do one. So I have total 15, which I guess is not that many, but you know, yeah. Okay, anyways, you guys ready? Sorry that I took you guys off on a tangent there. No tangent. Okay. Square root of 3 over 2 divided by half. So I need the x to be square root of 3 over 2. I need the y to be half. What rating is that? Not pi over 4, but pi over 6. To be TBH, pi over 6 plus pi will give me the 7 pi over 6, so I don't need the second equation. So I'm going to erase the subscript 1. Child, what are you talking about? If I add pi to pi over 6, that gives me the 7 pi over 6. So this will give me all of them. And then the last thing I do is just multiply by 3 to get x by itself. So x equals, let's see, 3 pi over 6, that's pi over 2, plus 3 pi n. So here are all my answers. Where's my domain between negative 6 pi and 6 pi? Okay. Pi over 2 is one answer. Add 3 pi to it. So I'm gonna switch this. Let's see, times 2. So 6 pi over 2. There's your 3 pi. So 6 plus 1 is 7 pi over 2. Excuse me. And if I add another 6 to that, 13 pi over 2, but I think that might be too big. 13 pi over 2 is 6.5 pi. Yeah, that's too big. Now go backwards. Subtract. 1 pi minus 6 pi, that's negative 5 pi over 2. And then negative 5 pi minus another 6 pi. What's that? 6, 7, 8, 9, 10, 11. Negative 11 pi over 2. And that one's in there, because that's only negative 5.5 pi. And that's it. Those are your 4. What's up?
So I understand how you did that, like the subtraction in the first one, like the first little equation. The second to last equation. How would you do that with this last equation?
How did I?
One near the bottom.
The negatives? I just did this.
X and 1x over.
The what?
Over 2 plus 6 pi over 2.
Yeah, that's 3 pi. I just did common denominator. I had a 2 in the bottom, so I just multiplied the 3 by 2. And I got my 6 pi over 2 like that.
Oh, okay.
See? Because that's still, this is still 3 pi. Well, it's 3 pi n. Where n is any number, right? 1, 2, 3. Can be positive. The n, it just means an integer. Okay. Do we have any more? Yeah. Okay, we're done with those. Now let's go to the ones where we're not using where they're not perfect. So before we continue, so I'm looking at the first page. So go all the way to the first page again. If they're not perfect coordinates, you could always, I mean, if you use logic, you'll always be able to figure it out. But here are the formulas, guys. If you don't want to do any thinking, you just look at this, and that's it. All right, let's focus. All right, so check it out. How do I use it? Okay, I guess first let's chat about where these formulas come from. All right, so where does the formula come from for the plus minus? It comes from this, guys. All right, guys, focus. So if I go cosine of theta equals square root of 3 over 2. Notice that to get theta by itself, theta equals, I put a plus minus in the front. But why? Why are we putting a plus minus in the front? Okay, I put a plus minus in the front because cosine is positive in quadrant 1 and in quadrant 4. And this is true. Notice that at this coordinate, I have a square root of 3 over 2, comma half. And notice that at this coordinate, which is symmetric to the x-axis, I have another square root of 3 over 2, comma negative half. And yes, you're right. Like Chav, we can just call that power 6 and call the other one 11 power 6. And you're right. But look, if I do this, isn't that also negative power 6? So that's why that plus minus comes in, because you can just go plus minus power 6 and you have both of them at the same time. You have that power 6 and 11 power 6. Chav, I don't see how you get the 11 power 6 like this. You take the negative power 6 and you add 2 pi to it. I get a common denominator, multiply by 6, that's 12 over 6. Oh look, negative 1 plus 12, that is 11 power 6. See? It works. You'll get all your answers with that for arc cosine with the plus minus. Yay or nay? Okay. Now I'm still going to focus on that coordinate, guys. So what about the sine? Okay, so I'm going to change the colors. I'm going to write sine theta equals a half. And to get theta by itself, you would go theta equals, I'm going to write theta 1. Theta 1 equals arc sine of a half plus 2 pi n. No, don't do that. Theta 2 equals, I'm going to write pi minus arc sine of a half. And I know, you guys already know that that's pi over 6. The calculator is stupid. No, it really is. It's just a machine. We program it. The calculator has faults. Whatever mistakes we make is what the calculator makes. No matter how hard you try, you guys know, and I guess it's pi over 6 for one of them, but the other one is, you guys know that where is sine a half? In quadrant 1 and in quadrant 2, right here. That coordinate is negative square root of 3 over 2, comma 1 half. That's the answer I want. I want the y value to be half. But no matter how hard you try, the calculator will not give you 5 pi over 6. Chav, I have no idea what you're talking about. Okay, here's what I'm talking about, guys. Let's find out what pi over 6 is first in decimal. So give me your A game, because it is a pretty important concept here. So just listen and see if you can understand the analysis here. Pi over 6, it's that decimal. Are we okay? Okay, so check it out. So if I type sine of pi over 6, I get that half. If I type sine of 5 pi over 6, I get that half as well. So no big deal. Are we okay so far? All right. Remember, pi over 6 is this decimal. If I go arc sine of 0.5, I do get this decimal up here. That's pi over 6. Are we still okay? But no matter how hard I try, I cannot get that 5 pi over 6 answer, even though sine of 5 pi over 6 is 0.5. See, look, the calculator just gives me this. If I can put, if you turn that into a negative and add 2 pi, it doesn't work. Negative and put that in there, and then put plus 2 pi. Oh, did I have not given you guys the decimal of 5 pi over 6? Okay, I'll show you. It's not that number. Look, 5 pi over 6 is that decimal. Do you see how it doesn't work? Like, no matter how hard you try, but look what does work. Look what my formula says here, and you'll see figured out real quick just by looking at the unit circle. This says here that I can get my second answer. Look what it says. Arc sine of a plus 2 pi n. It says I can get my second answer by putting pi in the front minus arc sine plus 2 pi n. So let's see if I do that. See if I get that answer. So let me, what was it, the 5 pi over 6 again? Let me type in the 5 pi over 6 so I know what that decimal is. And then look at this, guys. I'm going to go pi minus arc sine of what? 0.5. And then look at that. Isn't that cool? Okay, I know you guys are like, okay, so what, Chav? The reason why it works, I don't want you guys to become robots. The reason why it works is because your reference angle is pi over 6. This guy right here is pi over 6. And remember, it's always going to give you pi over 6 no matter what. So if you go pi minus pi over 6, that gives you your second answer. Does that make sense? So that's why arc sine has two equations. It splits it up into two. Okay, so that's why that works. All right, now last thing. Arc tan, guys, is always going to give you an answer between quadrant 1 and quadrant 4. And tan repeats every pi. So tan's not really that exciting. So yeah, so it's just this one equation or this one equation, because this gives you both. You know, so there it is. But well, okay, let me go ahead and explain. Where is tan 1? So I'm going to write tan theta equals 1. This is just so you guys can see where it's coming from. Well, I know that tan is 1 in quadrant 1 and in quadrant 3. That coordinate is square root of 2 over 2, comma square root of 2 over 2. And negative square root of 2 over 2, negative square root of 2 over 2. Well, this angle is pi over 4. So theta equals arc tan of 1 plus pi n. Well, how do I get the other one, the 5 pi over 4? Well, look, this is pi over 4, and I'm just adding pi all the time. So that pi, I just put a 4 over 4 to get the common denominator, and that's going to give me all of them. Theta equals pi over 4, comma, 4 plus 1, 5 pi over 4, comma, and I can just keep adding pi over and over again. Bless you squared. Cool or not cool? Okay. Yeah, bless you times bless you. Okay. Here we go. Example 1. Now we don't have perfect coordinates. Don't worry, guys. We're almost done. We're only doing 3 questions, and they're pretty fast. Now we don't have perfect coordinates, so now this is where you use formulas. So check it out. What do I do first? I'm going to rewrite it. 10 sine x minus 0.2 equals negative 3, and I wish I had a button that I can push for fire. What do I do first? Divide by 10. Sine x minus 0.2 equals negative 3/10. Get up to there. What do I do next? Inverse. We have 2 expressions. Here's my first one. I'm going to put up number 1. x1 minus 0.2, that's a subscript, equals arc sine of negative 3/10. And I'm going to change my color to show equation number 2. x2 minus, yeah, if you have colored pencil, this is a good one. Or if you have a different pen. x2 minus 0.2 equals, and I write what? No, I don't write arc sine. Perfect. Pi minus arc sine. Here's if you want to show it algebraically. All right, focus on these, focus. Negative 3 over 10 plus 2 pi n. Oh, I didn't put the 2 pi n on the other one. Plus 2 pi n. There it is. This is how you show it algebraically, guys. If I don't ask you for algebraically, if I just tell you to show it graphically, then just find the intersection. Then that's all you do. It does want me to verify the solutions graphically, so I'm going to do that in a little bit. Are we okay with what we did? All I did was use this. Now make sure you're not a robot. All I did was use this. I used that right there. Make sure you're not a robot. Make sure you understand why we wrote pi minus whatever. Okay, now I'm trying to solve for x. I'm just going to move the 2 to the other side. I just move it right in front. Plus, it's not a product, so you're just adding 0.2 plus arc sine of negative 3/10 plus 2 pi n. Yeah, I haven't done anything crazy. I just moved the 0.2. I take my calculator. Make sure your mode is in radian mode. And it's going to be a decimal because it doesn't have a pi on it. This one's going to be, it's not a perfect coordinate. So, I mean, no coordinate's not perfect, right? But 0.2 plus arc sine, I already forgot, negative 0.3. Negative 3 over 10. Negative 3 over 10. Enter. I'm going to write negative 0.10469. Let me see if I can remember that. x1 negative 0.10469 plus 2 pi n. That's a radian. And I'm going to go back to the black one over here. I'm going to go x2 equals 0.2 plus pi minus arc sine of negative 3/10 plus 2 pi n. If you like to do this first, then that's fine. Not a big deal. You can just drop the parentheses. It doesn't matter. So here we go. 0.2 plus pi minus arc sine. Let's see. Well, I remember. 0.2 plus pi. The pi is where the caret symbol is at. Minus arc sine of negative 3/10. I know I could have done minus the top, but I always want to make sure, I would just do that. Enter. And 3.646285. 3.646285. 3.646285. X2 equals 3.646285. Make sure that's correct. Are we okay so far? Faux show. Okay, for sure. Sorry. All right, here we go. I'm going to write all my answers now. All of them. X equals, the very first one is this one right here. 3.6463 if I round it. 62 if it's truncated. The next one is going to come from the negative. So I go to my calculator and I'm going to add. By the way, in case you're wondering, Chav, what are you doing? I'm finding all the answers between 0 and 4 pi. Yeah, I slowed down. I saw you guys. So what's 4 pi? In case you want to know what 4 pi is in decimal, 12.566. Yeah, that way, Chav, why did you do that? Because I want all the answers between 0 and 12.566. So as long as you haven't gone above 12.566, it's an answer. What's up, Bernal? Hit me. No, well, this means I want all the numbers between 0 and 4 pi, between 0 and 12.566. So that's why I didn't include the negative in my answer choice. See? I'm going to add 2 pi to it. Well, yeah, you got to ask, guys. So here we go. I scroll up to the negative, and I add, what am I adding to it? 2 pi. So plus 2 pi. And I push enter, and there it is, 6.1785. 6.1785, comma. Then I go back to 3.6463, and I'm going to add what to that? 2 pi. So I scroll up, push enter, plus 2 pi. I think that one might be, nope, still good. 9.9295. 9.9295. Now I take the 6.1785 and I add 2 pi. 6.17 blah 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 plus 2 pi, and I think that one's barely in. 12.4617. 12.4617, and that's it. If you take the 9.9295 and add 2 pi, you'll be outside of your domain. Oh, we still haven't proved it graphically, but what's up? No, we're just verifying. That's just to verify. Say it again. Yeah, I'll show you. I'll write it here. This one is coming from X2. This one is coming from X1. This one's coming from X2. This one's coming from X1. So for the second, the 6.1785, I took the negative 0.104 and I added 2 pi to that sucker. Yeah, I took the negative 0.10469 and I added 2 pi. And the 9.92, I added 2 pi to the 3.646. And for the 12.46, I added 2 pi to that one. All right, guys, I want to make sure that you're not going through just the motions and just doing it blindly. What exactly did you just do right now? Well, remember, one of your skills from your algebra days is to type that into Y1 and to type that into Y2 and to see where they what? Intersect. So that's exactly what I'm going to do. So take your calculator. It might already be in there from earlier. On Y1, I'm going to type in what I have on the left side. What was it? 10 sine. What did I have on the inside? X minus point what? 0.2? Oh, I thought I put 0.3. Okay. And on Y2, it was what? 3? Negative 3. Okay. Before you push graph, Don't push graph yet. I haven't done anything, guys. All I'm doing is plugging into y1 and y2. I want to see where the left side equals the right side. Before you push graph, make sure you're in radian. Go to mode, and it's right here, radian and degree. Okay. Okay, in case you guys are wondering what I'm doing, I am typing this into y1. I'm going to go slow. This guy into y1, and I'm typing this guy into y2, and I'm going to see where they intersect. This is an algebra skill from your algebra 2 days, or maybe even algebra 1. I'm not sure. All right, here we go. Click on window. I'm going to go x min 0. All right, guys, focus, focus. I'm going to go x max 4 pi, because that's what it told me to look, only between 0 and 4 pi. I'm going to leave, I'll leave the negative 10 and 10 alone. Push graph. No, you're fine, you're fine. Window, I left my y min and y max as negative 10 and 10, because the amplitude was 10. Yeah, because the amplitude of your sine function is 10, because there's a 10 in front of the sine. Remember the amplitude? No, it doesn't matter. As long as you see the negative 3. Yeah, those big bulky calculators are slower. If you have a skinny TI-84 CE, those will be a lot faster. All right. Does everyone graph look like that? All right, make sure you practice, guys. Practice. All right, check it out. I am going to find these intersections, and I bet you it's going to be those same values. So look, second calculate number 5, and then I'm going to, you only have 2 curves in there. Enter, enter. Focus, guys, focus, focus. When it says guess, scroll to the one you want and push enter. Is one of my answers 3.646? Is that one of your answers? Yes. There it is, where it works. Second calculate number 5, intersect. I'm going to enter twice and scroll to the one you want. When it says guess, scroll to the one you want. Enter. 6.178. Is that one of your answers? Yes. Second calculate. Look, I'm doing it again. I'm doing it again and again, guys. Number 5, enter, enter. First curve, second curve. When it says guess, you scroll to the one you want. I want this third one here. I push enter, and it says 9.929. Is that another answer? Okay, look, I'm doing it again. One last time. Second calculate number 5. I'm going to enter twice. First curve, second curve, guess. I want this fourth one way out there, almost, it actually zoomed, almost to the end of that. And it says 12.4616. There it is, guys. I think I must have rounded it to 7 maybe. But there it is. Cool or not cool? Can we do that over and over again? Okay. All right. So there it is. Now look how beautiful all that math looks. Okay. So let me warn you in advance. On your exam, I am going to at least ask one algebraically. I'm leaning on a cosine, but make sure that you're able to do a sine one as well. I'm at least going to ask one. If you do not see the word algebraically, just find the intersections. Type it in your calculator. Does that make sense, guys? So I'm not going to make you do this over and over again on the test, but I will at least ask one time for you to show me that you can do the algebraic manipulation. Cool or not cool? Okay. All right. Here we go. We're going to do a simple one. Here we go. We're going to do a simple one, guys. We're just doing, tan is not all that exciting, but let's do it anyways. I already put it in here. It says in degrees. So here we go. I take my calculator. All right, guys, focus, focus, focus. I take my calculator and I put it in what? Degrees. So there it is in degrees. And so right now, here I am, and it says degrees in the top right there. Push mode and then go to degrees. Mode is next to the y equals. All right, here we go. I'm trying to solve for x. I'm going to rewrite it. 4 tan x equals -5. What's the first move? Divide by 4. Tan x equals -5/4. What's my next move? Yeah, arctan or inverse tan. Perfect. X equals arctan or inverse tan. It doesn't matter. Negative 5/4. You're in degrees. Plus, tan does not have 2 pi or 360. Yeah, it's 180. It's right here in your notes. And it says right there in degrees, 180. So make sure you have this with you. I'm going to put plus 180 degree with a little n on it. Are we still okay? Check it out. You take your calculator. Look how powerful the calculator is, guys. Look what it can do. You can just push enter, and it'll always give you your answer. Look, this is what I love about TI. Not all calculators are like this. Focus, guys, focus. Arctan, what was it? Negative 5/4? I'm going to push enter, and then look, is that one of my answer choices? Like, is that an answer? It says, what was their instructions? I'm sorry. The first 3 positive. Is that one of them? No. Look, here's what you do. Push the plus button. It's going to say A and S. That stands for answer. 180. Push enter. 128.6598. Type that down. X equals, and I already forgot. What was it? 6598. Put a little degree symbol, comma. Check it out. You don't have to push. You don't have to do it again, guys. All you got to do is push enter. It's going to do the last. This is like coding. This is like code. It's going to execute your last line. All right, guys, focus, focus. Look, you just push enter. Bam. Look at that. This is why I tell you that the TI-84, you can be so fast with the TI-84 if you learn how to use it correctly. 308.6598. 308.6598. Just push enter and it'll do it again for you. Enter. And look, it does it again. It just keeps adding 180 to your last input. 488.6598. And there it is, my first 3 positive ones. How do we feel? All right. Go to the next one. Don't worry, we just got 2 left, and then that's it. All right, relax, relax. Before we continue, I want to say that I've said this before, but I'm not sure. Do you guys know that square means this? I have said that before, no? Oh, man. Okay, go ahead and write it down. That's what it means. Sine squared x means that. If you're trying to square the sign, do not say this. That means that your argument is squared. Chav, what's argument mean? Argument means whatever's inside your parenthesis there. So that does not mean sine squared x. That's the most common mistake. Chav, what does that even mean? It means this. If I write sine squared of pi over 4, I'm just doing something simple, guys. This is still a side note. Well, what is sine of pi over 4? Not everyone at the same time. Square root of 2 over 2. That means that number squared. So it means 2/4, which reduces to 1/2. That's just side note for you guys. Okay, unit circle. What's sine of pi over 4? Square root of 2 over 2. I'm going to have to bring those unit circles back. And then that says that it's sine squared, so I'm squaring just what sine is. Square root of 2 over 2 squared. Yeah, look, guys. You can always do this. So you can always say, oh, that sine of pi over 4 squared. So sine of pi over 4 is square root of 2 over 2. See? Okay. All right. Now that we got that out of the way, if your algebra is weak, if your factoring is weak specifically, you might have a hard time. No, it's simple, guys. Look how simple this is. Look. This is similar to x squared minus x minus 2 equals 0. Do you remember how you did that when you were in Algebra 2? Okay. Do you know how to factor x squared minus x minus 2? Yes. What are my factors? Yeah, but x minus 2, x plus 1. Are we okay with that? Okay. So now, what were my solutions when you were in Algebra 2? Well, x equals 2. 2 minus 2 is 0. 0 times anything is 0. That's why it's so useful to equal stuff to 0, right? Because it's so easy. And what else would make it 0? Or if x is negative 1. Negative 1 plus 1 is 0. And 0 times anything is 0. Cool or not cool? Cool. Okay. Next. If that is similar to that, that means this expression can be factored to this. Sine x minus 2 sine x plus 1 equals 0. You can. Sometimes textbooks don't put them. It's called an argument. And textbooks should start putting them because it's not like it's similar to f of x. You don't say f. So they should start putting them, but sometimes they put them, sometimes they don't. Cool or not cool? All right, next. So that means sine x has to equal 2, which we know is not possible. And sine x has to equal negative 1 in order for this to be 0. That one is possible. All right, focus, guys, focus. Sine x cannot be 2, guys. Sine x is between negative 1 and 1. Because in the unit circle, the biggest sine x is 1, and the smallest sine x is negative 1. If you were to try to put this into your calculator into y1 and y2, they would never intersect. Cool or not cool? Okay, but this one is possible. This one is possible, guys. Don't worry, we're almost done. On the unit circle, sine x is negative 1 down here. They want my answer between negative 9 and 270, but not including 270. So can I say 270 degrees is an answer? No, because look, there's a parenthesis. 270 can't be it. But look what it has for the negative 90. It has a bracket. Can I be negative 90 degrees? Yeah, there it is. That's negative 90 degrees. So the answer, there's only one. Negative 90 degrees. Done. What happened, Miss Kanduru?
Why is it not 2 again?
Oh, sine x will never be 2. Sine x is between 1 and negative 1. On the unit circle, you don't go past 1, and you don't go smaller than negative 1.
So it's never equal.
It will never equal 2. Unless you have an amplitude in the front of 2 or 3, then it will. But it'll never be 2. Look, you can... I want you to be definitive about it. Look, if I put sine x in here, and I put the number 2 in y2, it will never intersect. Delete. Let me click on my window. I'm going to go between 0 and 2 pi because I'm in degree mode. Okay, so let me go between 0 and 360. I'm in degree mode. X scale by 90 for every 90 degrees. Y min negative 3. Y max 3. And look, they never intersect. They never touch. What's up, miss?
How did we get power before in the very beginning?
That was a side note. That was a side note. That was a side note. It had nothing to do with the problem. All this is a side note. Yeah, I was just explaining about the square. All right. All right, guys, let's focus. Last one. It is not uncommon for you, if you're entering the workforce, you guys will find this out as you become more, as you guys become adults. It is not uncommon that if you're becoming an engineer, they're going to ask you engineering questions because they're hiring you, and they want to make sure that you know engineering work. If you're becoming a doctor, they're going to test you on what knowledge you have. If you're becoming a lawyer, they're going to test you on entry-level lawyer information. So if you're going to work and it's a specific job that requires a specific skill, they're going to ask you that skill because they have to. So here it is. Here's a problem. You're an engineer and they ask you to solve this question. All right, guys, focus, guys. This is similar to 4x squared minus 2x minus 3 equals 0. You cannot factor this one out. You can look at it and you're like, oh, the AC method. Well, you can try the AC method. It won't work. Oh, guess and check. You can try it. It won't work. You can't factor it out. So when you were in Algebra 2, how would you solve this equation? It starts with the letter Q. quadratic equation. Guys, this is a build-up. Like you guys wanted AP, so here we are. All right, here we go. This is a build-up. The quadratic formula is not going to go away. What you've learned in previous algebra classes is not going to go away. If you have issues with algebra, come in and we'll talk about algebra. All right, here we go. Your A is 4, your B is -2, and your C is -3. I'm going to say X equals, because right now I'm just solving this algebra problem, -B, I guess I'll write the formula first, -B square root B squared minus 4AC, all this is over 2A. So here we go. X equals opposite of -2, so 2 plus minus square root. If you want to put the -2 to be technical because it does say B, then go for it. You're squaring it anyways, so it's going to turn to a positive. Minus 4 times -3. And all this is over 2 times 4. We're going to type it into the calculator real slowly. So here's my calculator. I'm going to go to the home screen, second quit. And am I still in degree mode? Let me check what mode I am. Nope, I want it in radian. So change your calculator to radian mode because we're going to be using these answers in a little bit. Radian. All right, so here we go. I'm going to push alpha y equals to get the fraction. So you see the little fraction there? All right. Come on, Ruthie, focus, miss. So here we go. And I type in 2. So type in 2 plus second square root. And it's up to you if you want to put a -2 squared. It doesn't matter. I guess I'll put -2. But put it in parentheses or else it's going to turn to a negative. -2 squared minus 4 times, what was A? 4 times -3. And then all this is over 2 times 4. Yeah. 1.15138. Can we be that? Well, I guess X can, but sine can't. Yeah, X can. X equals 1.151387. 1387. Truncated, not rounded. It should be 88, but that's fine. All right, and now I'm going to do the minus. All I do, I don't see any mistakes. Let me know if you see any mistakes. I push enter, and I switch that plus to a what? To a minus. So I just go all the way to the plus. I put a minus. Enter. -0.651388. X equals -0.651388. Did I remember that? 651388. Okay. All right. Because it's similar, that means this, I can set, instead of X, I can say sine X equals that. So I can go sine X equals 1.151387. Can I be that? Can sine X be that number? It cannot. Sine X has to be between -1 and 1. But sine X can be this one. What happened? This one is possible, guys. We're going to have to do 2 equations for that one. So write that down. Don't worry, we're going to go slow. Are we still okay? How do I get X by itself? Arc sine. So here we go. I'm going to come over here. That's the only one that's possible. Just this one. So write X equals arc sine of -0.651388 plus 2 pi n. That's equation 1. And I'm going to write equation 2 over here. I know I'm going to need more room, so I'm going to write it right here. X2 equals, what's my second equation? What did I put in the front? We talked about it. Pi minus arc sine of -0.651388 plus 2 pi n. And I want all my answers between 0 and 2 pi, so I'm not going to be adding 2 pi unless it's negative. So here are my answers. X equals, let's see. I take my calculator, and I'm going to go arc sine first of this. I'm just going to scroll up and push enter. enter. Negative 0.709. Okay, that's one answer plus 2 pi. Well, the plus 2 pi will be. Negative 0.709 plus 2 pi n. I'm going to add 2 pi in a little bit. That's x1. Here's x2. I'm going to do pi minus that. Pi minus arc sine of this angle right there, or this radian, and then close, enter. 3.851. 3.851 plus 2 pi n. Okay, finally, here are your answers. You only have two. Answers. NS. X equals this one, 3.851, comma, and then I guess, well, yeah, and the other one is this negative 0.709 plus 2 pi. So I just go back to my calculator, and I look for the negative 0.709. I push enter, and I go plus 2 pi. Don't worry, we're almost done. And 5.57377. 5.57377. Done. Those are my two answers. I would verify them with a calculator to make sure those are it. So I'm going to type this into my y1 in a little bit just to make sure. Actually, this is a pretty cool curve. You're going to like it. Yeah. Y equals clear, and it's equals 0. Yeah, you're going to like this curve. This is the cool one. 4 parentheses sine x, close it. This is how you put the square on it, squared. And I already forgot, what was it? Minus 2 sine x. Minus 2 sine x, close it. And then what was the last one? Plus 3? Minus 3. Minus 3. And that's it. I'm going to go to window. I'm in radian, so 0 to 2 pi. And I want to go by pi over 2. Pi over 2. What was my negative 5 to 5 should do it. Look how cool this curve is, guys. That could be a signal to your cell phone or something. That could be a very unique code. Like, you know how you need specific... Okay, I know you. I wish you guys were already like well versed with oscilloscopes and signal analysis. Every time you push unlock on your car door, how come only your car unlocks and not any of the other cars? Because your car, in essence, your vehicle has a unique frequency that is tied. It's like a wave. So this is your only wave that unlocks your car, but it won't unlock any other car. So as soon as this wave comes on the screen, on the oscilloscope, oh, unlock. Boom, unlocks. Isn't that cool? Okay, I think it's cool. All right, real quick, guys, just to figure out, just to make sure that we got the right answers, here's how you do this one. Notice that it equals 0. So in math, when do you cross the x-axis? When does the y value equal 0? When you cross the x-axis. I accidentally give you the answer there. So look, here's what you do. Don't worry, we're almost done. Give me like 2 minutes. Second, calculate. Number 2, 0. And then it says left bound. Okay, to the left of the 0 that I want. Right bound, you go to the right of the 0 that you want. If you have several zeros, then it says guess, go to the one you want. There's only one right there in between there. I push enter. It's 3.851, one of them. Is that one of the, okay, there it is. There's one of the answers. Let's look for the other one. Second, calculate. I push number 2, 0. We need a 0, not a hero. Okay, that was stupid. Okay, sorry, guys. All right, enter. I'm going to go to the next one. After I pass this guy, I'm going to push enter. And then look, 5.5737. Is that another? There it is. We got it. Cool or not cool? I hope that you guys understood today. Right now, go ahead and log into the Delta and do the simple ones. On Wednesday, we'll practice the harder ones.